Hello. Hello everyone. Today we shall discuss about this one, that is motion in a plane. Now we shall Hello. Hello everyone. Today we shall discuss about the chapter that is motion in a plane. So sorry for to discuss about motion in a plane. Now see that motion in a plane, we discussed that in the last chapter we have developed the concepts of position, displacement, velocity and acceleration. We found that the directional aspect of these quantities can be taken care of plus or minus sign, as in one dimension only two directions are possible, but in order to describe motion of an object in two dimension plane or three dimensions we need to use vectors to describe the above mentioned physical quantities. Therefore it is first necessary to learn the language of vectors. What is a vector? How to add, subtract and multiply vectors? What is the result of multiplying a vector by a real number? We shall learn this to enable us to use vectors for defining velocity. What is the result? We shall learn to enable us to use these vectors. We shall learn this to enable us to use vectors for defining velocity and acceleration in a plane. We then discuss motion of an object in a plane as a simple. We shall learn these to enable us to use vectors for defining velocity and acceleration in a plane. We then discuss motion of object in a plane as a simple case of motion in a plane. We shall we shall discuss motion with constant acceleration. In the last chapter, we developed the concept of position, displacement, velocity, and acceleration that are needed to describe the motion of an object along a straight line. We found that the directional aspect of these quantities can be taken care of plus by plus and minus signs. As in one dimension, only two directions are possible, but in order to describe the motion of an object in two dimensions, a plane or three dimensional space, we need to use vectors to describe the above mentioned physical quantities. Therefore, it is necessary to learn the language of vectors. What is a vector? How to add, subtract and multiply vectors? What is the result of multiplying a vector by a real number? We shall learn this to enable us to use vectors for defining velocity and acceleration in a plane. We then discuss motion of an object in a plane. As a simple case of motion in a plane, we shall discuss motion with constant acceleration and teach in detail the projectile motion. Circular motion is a familiar class of motion that has a special significance in daily life situations. We shall discuss uniform circular motion in some detail. The equations developed in this chapter for motion in a plane can be easily extended to the three dimensions. Now we'll learn about scalars and vector. In physics, we can classify quantities as scalars and vectors. Basically, the difference is that a direction is associated with a vector but not with a scalar. A scalar quantity is a quantity with magnitude only. It is specified completely by a single number along with the proper unit. Examples are the distance between 2 points, or mass of an object, the temperature of a body, and the time at which a certain event happened. The rules for combining scalars are the rules of ordinary algebra. Scalars can be added, subtracted, multiplied, and divided, just as ordinary numbers. And what is a vector? A vector quantity is a quantity that has both a magnitude and a direction and obeys the triangle law of addition, or equivalently the parallelogram law of vector addition. So a vector is specified by giving its magnitude by number and its direction. Some physical quantities that are represented by vectors are displacement, velocity, acceleration, and force. To represent a vector, we use a boldface type in this book. Thus, a velocity vector can be represented by V. Since boldface is difficult to produce when written by hand, a vector is often represented by an arrow placed over the letter. Say this is the vector by notation. Thus, both V and V represent the velocity vector. The magnitude of a vector is often called its absolute value, or denoted by modulus of V, that is V. Thus, a vector is represented by boldface A, capital A, or this, with respective magnitudes denoted by lightface, capital A, lightface, this one. In this way, we get the vectors. Now, we will learn the position and displacement vectors. To describe the position of an object, moving in a plane, we need to choose a convenient point, say O as origin. Let P and P dash be the positions of the object at time t and t dash respectively. We join O and P by straight line. Then OP is the position vector of the object at time t. Hello. Now here you get that to describe the position of an object moving in a plane, we need to choose a convenient point, say O as origin. Let P and P dash be the positions of the object at time t and t dash respectively. We join O and P by straight line. And OP is the position vector of the object at time t. The point P dash represents another position vector denoted by R dash. Here see the length of the vector represents the magnitude and the vector of and the length of the vector R represents the magnitude of the vector and its direction is the direction in which P lies as seen from O. If the object if the object O moves from P to P dash, the vector P dash is called the displacement vector. P dash is called the displacement vector corresponding to the motion of the point P at t to point P dash. You see, if this is a displacement vector, suppose this P is the position vector of an object and this P dash is another position vector of another object. And if this is a position vector, this is represented by R and this is the position vector R dash, and if we extend this P to P dash, this is the displacement vector, right? And displacement is this is a displacement vector corresponding to motion from point P at time t to point P dash. Position and displacement vectors. Displacement vector PQ and different courses of motion. Here you see, wherever we go to another in this direction, whatever the answer will be PQ. Whether I go in this direction or in this direction or you go in this direction, the vector will be from the initial point to the final point. This is the resultant, right? That is the displacement vector PQ for different courses of motion. It is important to note that displacement vector is a straight line joining the initial and final position and does not depend on the actual path undertaken by the object between two positions. Now, for example, in figure 3.1b, given the initial and final position as P and Q, the displacement vector is the same PQ for different paths of journey, that is P, B, A, B. I already told you, right? Is therefore the magnitude of displacement is either less or equal to the path of length of an object between two objects, right? The magnitude of displacement is either less or equal. This fact was emphasized in the previous chapter, also discussing motion along a straight line. Now, if you find equality of vectors, two vectors and we are said to be equal. When the two vectors are equal, that is this one, that is two vectors. This is vector A and this is vector B. These two vectors will be equal only when their magnitude and direction is same. Only when their magnitude and direction is same. That only they are equal as equal vectors. Now we learn another important thing, that is this one. Addition and subtraction of scalars makes sense only for quantities with same units. However, you can multiply, divide scalars at different units. In our study, vectors do not have fixed locations, so displacing a vector parallel to itself leaves the vector unchanged. Such vectors are called free vectors. However, in some physical applications, location or line of application of vector is important. Such vectors are called as localized vector, right? Therefore, it is called as localized vector, and these are sometimes called free vectors. Now we learn other thing, that is this one. These are known as, such vectors are called localized vectors. Now we learn other things, that is this one. This one is what you see. This one is multiplication of vectors by real numbers. If we multiply a vector by real number, since multiply by real number, that is this one. That is, if we multiply a vector, suppose we are multiplying a vector by lambda, then since lambda is a constant, it will come out and it will be modulus of a vector. And here you see that lambda is greater than 0, right? This is way multiplying a vector by negative number. Minus lambda gives another vector whose direction is opposite to the direction of A, whose magnitude is lambda times magnitude of A. Right? In this way, we can define these vectors. Now, addition and subtraction of vectors, this is the graphical method. This is the graphical method. As mentioned in section 4.2, vectors by definition obey the triangle law, or equivalently the parallelogram law of vector addition. We shall now describe this law of addition using the geographical how to add two vectors. That is important for us. You see here, if these are A and A, we can add the vectors because they are in the same direction. A plus A is 2A. You can see here that how we add two vectors. Suppose this is a vector A and this is same vector A. Since they are in the same direction, we will get a resultant of 2A vector in the same direction. And this is suppose A and this is minus A. If we add the two vectors, we got a 0 vector, right? That is resultant is 0. And here also see the vectors have different directions. Suppose this is the vector is A and we replace this vector B in this position, right? And if we take the or we can replace this B as this position. In this way, we can replace the vector because this is parallel to this one. So this will be the vector addition. This resultant will be vector A plus vector B. Here also see this is vector A, this is vector B, right? So if you add this one, or we can add in another way, this is A vector and this is B vector. We can give it in this direction. You see, this is A vector. We have to replace this vector in this direction, or we can in this direction. Therefore, resultant will be in this direction. So we can add the vectors. We can in different way, and the addition we have two. One is vector law of triangle law of vector addition. Triangle law of vector addition. And the second one is parallelogram law of vector addition. Parallelogram law of vector addition. And there is third one also, polygon law of vector addition. This is known as polygon law of vector addition. Polygon law of vector addition. Vector addition. Now we will learn all these vectors in detail. Now let us learn these vectors. Suppose I want to learn these vectors in detail. So for detailing, we are going to this one and you see how we are describing this one. You learn how to describe this one. You see here that we describe this one here. this one. How to add two vectors that are going to discuss here. Suppose first one is, we already told you that is first one is triangle law of vector addition. This is triangle law of vector addition. And number two is parallelogram law of vector addition. Parallelogram law of vector addition. And the third number, what we say is this one. That is polygon law of vector addition. Polygon law of vector addition. First we learn the triangle of vectors. Suppose there are two vectors. This is vector A. This is vector B. We add the two vectors, that is initial point of the first vector and final point of the last will be joined. This is the resultant vector. This is R. This is vector A plus vector B. So there is another vector. This is vector A and this is vector B. This is not the angle between A and B. We extend this vector here. Suppose this vector is A and this vector is B. Right? So we extend this vector here. So what we'll do, we will replace this vector A here. Now you see, this is the vector A. This is initial point of the first vector and this is the final point of the last vector. So this is the resultant. R vector equal to A vector plus B vector. Okay, in this way we can do. Now this is A vector plus B vector, and if we use the parallelogram of vector addition, suppose there are two vectors. This is vector A and this is vector B. This is vector A, this is vector B. We place this vector here in this direction. So this is vector B, and if we complete a parallelogram, the diagonal will show the resultant vector. This resultant vector will be vector A plus vector B. This is the resultant. This is the polygon parallelogram law of vector addition, and this is the triangle law of vector addition. And the third phase, what we call the polygon law of vector addition. Suppose there are three or more vectors. Suppose there is a vector here, 5 Newton, There is a vector here 2 Newton. There is a vector here 5 Newton, and the resultant will be initial of the first vector and final point of the last vector. That is these 2 Newton will be the resultant. This is the vector. This is the resultant vector, right? So this is the resultant vector. Vector A plus vector B. If we add all the vectors, then R vector, the resultant vector will be vector A plus vector B plus vector C. Right? In this way you can so this is the polygon law of vector addition. Right? So we applied three, that is triangle law of vector addition, parallel law of vector addition, and polygon law of vector addition. Again, if you see, this is vector A, this is vector B, this is vector C, this is vector D. The resultant will be initial point of the first vector, the final point of the last vector. This is the resultant vector. Therefore, resultant vector we will get here is vector A plus vector B plus vector C plus vector D. That I am going to get this vector only. Hello. So we have got three laws of vector. One is triangle law of vector addition, parallel law of vector addition, and polygon law of vector addition. So we learned the three laws of vector addition: triangle law of vector addition, parallel law of vector addition, and polygon law of vector addition. So these are the three rules of vector addition, and the next day we learned the general formula for vector addition, right? Therefore we are getting all these formulas. Okay. Now we learn some vector addition of orthogonal vector addition. Now if this is a two-dimensional vector, may we discuss vector in two dimension, vectors in two dimension, in two dimension. That is, suppose this is OX direction and this is OY direction. This is position vector P, represented by R, and this is given by X and Y. That means this value is X and this value is Y. If we consider this vector as R, then we can write vector R is equal to xi vector is unit vector plus yj vector. And if we use three-dimension vectors in three dimensions, then it will be OX, this is OY, now Z vectors, and this is the position vector P. It can be defined as X, Y and Z, and suppose this is the position vector P, then this vector can be represented in this way, that vector R. Vector R is equal to xi vector, this is unit vector I, plus yj vector plus zk vector. This is the vector R. Thank you everybody for watching this video. Thank you. If you like this video, please subscribe, like and share. Thank you everybody for watching this video.